What's going on, everyone? You're back with Jono for another quick math lesson. Today we're going to have a look at multi-step experiments and see what the probability of these things occurring is. So this is kind of like in a game where you need more than one thing, multiple things to occur in order for you to win. Because of this, we can't just use our what we want divided by what could happen, because there are heaps and heaps of kind of outcomes that could occur based on one thing or another. But the best thing for us is these are quite easy. The mathematics, again, is not too difficult. It's just kind of reading the question and interpreting what we need to find. That is the difficult part. So we're going to break these into two different categories: equal outcomes and unequal outcomes. And we're going to start with the equal outcomes. In order to do this, we can just use lists and tables to get our answers really quickly. So for this game, we have to hit two heads in order to win. Because getting heads or table is an equal outcome, both 50%, we don't have to do any actual maths in order to get this right. What we need to do is write an outcome list, or what could happen. So I could get a head, I could get heads tails, I could get tails heads, or I could get tails tails. So I've got four outcomes that could happen from flipping a coin 2 times. But I only win if I get 2 heads. So my answer is what I want, heads, divided by what could happen, which are the 4 that I've said. So my answer is just 1/4, done. Now in another game, I have to flip a tail and roll a 3 in order to win. So I can do this in a table or an array. Because my options for the coin are head or tail, and then I've got 6 options for the die, I can write it out like this and just fill it in, kind of just connecting 2 things. So all you have to do is just go across and write all of these things in, exactly the same as I'm doing just here. Then all you need to do is work out, how do I win? Oh, tail 3. So there's only one option out of these that gets me the actual win. And then I just have to divide that by all the possible outcomes. You can count out pretty easily that there are 12 outcomes. So my probability is 1/12. So the actual formula, sometimes we don't want to write a list or draw a table, is just the probability of A multiplied by the probability of B. And we'll just see for those 2 examples how easy it is. For the coin, I needed a head and then a head. Getting a head the first time was a 50-50, and then a probability of getting a head the second time was 50-50. So I just have to do a half times a half, which is equal to a quarter, which is what I got from my list. Then if I looked at the other one, the probability of getting a tail was a half multiplied by getting a 3, which is 1/6. A half times 1/6 is 1/12, which is again the same thing. So instead of drawing these tables out, if you remember multiplying the probabilities together, that's all you need to know. So your calculator is going to do all the work for you for these questions. So the other type of questions we could get is when we've got unequal probabilities. So this is where one thing is more likely than another, but we still want to kind of work out what could happen over multiple outcomes in order for us to get the win. The best thing about this is that PA times PB, or the probability of A times the probability of B, still works out. It's just way harder to draw out a table, so we're just going to use the mathematical multiplication in order to get these right. So for this example here, I've got 7 green marbles, 4 red ones, and 3 blue ones. So pulling out 2 of these marbles and putting them back in is going to give me a different answer for each one, depending on the probability of green, red, and blue. The first thing I want you to do for these questions every single time is work out how many in total you've got. So 7 plus 4 plus 3 is 14, and I would write that down immediately. I've got 14 marbles in total for me to choose from. What we're doing in this game is we're going to take one, write down the color of it, and then put it back in. That's actually really important, and we're going to get into it in the next lesson. One more thing that is important here is that the order does matter, right? We get into a whole different branch of mathematics when we start mixing the orders around. But for all of these questions that we're doing today, please just make sure we know that the order is important, right? If I say green, then red, you have to get that. So for this first one, the probability of getting green and then the probability of getting red is 7/14, because half of them are green, multiplied by 4/14 because there's 4 red ones. You just have to throw that into your calculator. It'll give you the simplified answer. For this one, it's 1/7, done. So that's all you need to know. For this next one, we're looking at the probability of getting blue than blue. So that's 3 over 14 multiplied by 3 over 14. And that's just equal to 9 over 196. These don't simplify, so that's your final answer. So these are pretty easy. You could put this into a percentage just to make a little bit more sense to yourself. And if you throw that into your calculator, change it to a decimal times by 100, you get 4.59%, which makes a lot of sense. It's not happening that often. For this last one, we've got the probability of green, then blue, then red. So again, the order does matter. I need it in exactly these steps. So I've got 7 over 14 multiplied by 3 over 14 multiplied by 4 over 14. Put them in your calculator. That's all you've got to do. This is equal to 3 over 98, which is about 3%, because this is not a very likely outcome. So it kind of all makes sense. So the maths for these are not too difficult. I don't want you to stress out. It's just reading the question, making sure we know what we have to multiply together, and the calculator will do the work for you. Thanks so much for watching these ones, and I'll see you later.